Hi, in this video we will do examples in which we use cross product to complete a task. So here there are two properties of the cross product that you have to have in mind at least. These are geometric interpretation of U cross V. The first one is that it comes from the direction of the vector U cross V. U cross V is a vector orthogonal to both U and V. Well, you remember the right hand rule. So if you have UV, then this is U cross V. It's a vector orthogonal to both U and V. And well, about the length of U cross V, we know that it is equal to the area of the parallelogram determined by U and V. So this is UV. So if you fix any non-parallel vectors UV, that will fix you a parallelogram. The area of that parallelogram is given by the length of this cross product. Okay, so these are two things that you have to have in mind. Let me do examples that I have prepared for you. Yes, here. So the example one has information about some planes, and the question asks to write their general form. First one says the plane passes through the point 101 and is parallel to two vectors U and V. So if two vectors U and V are parallel, then remember that to write general form, I can use U and V and find the vector form, but I'm looking for general form. For general form, I need a normal vector. So normal vector is a vector which is orthogonal to all vectors parallel to the plane. So if I cross product U and V, I can get a normal vector. Remember, compare this with the case of the lines in the plane. When you have vector form or direction vector for a line in R2, going to normal is just easy. Just flip two components and multiply one of them by negative sign. But here in R3, it is a bit difficult. I mean, it's different. And you have to take as cross product of the pair of direction vectors given. Okay, so in this case, I have 2, -1, 2 cross 0, -1, 3. This is a good example to do the cross product. Remember that the trick 2, 0, -1, -1, 2, 3, and then 2, 0, -1, -1. Let me write this 0 a little bit further away. Okay, then ignore the first row. Then you have this guy here. -1, 3 minus 2 times -1. The other one is 2 times 0 minus 2 times 3. And for this one, 2 times -1 minus -1 times 0. So this, when you complete the result you see here is going to be, okay, -3 plus 2 is -1. This is -6, and the other one is -2. We have normal vector, then we go ahead and write n dot x equals to n dot p. Start with the normal form and then simplify it to the general form. Normal is this guy dot x y z equals to -1, -6, -2 dot. The point is 1, 0, 1. So this gives us -x minus 6y -2z equals to -1, 1 times that, and plus 0 minus 2. So the final result is minus x, negative x minus 6y minus 2z equals to -3. That is the equation in the general form for this plane. The other one, part 2, says, well, find the general form of the equation for the plane which has vector form. So vector form is given. We are asked to turn it into general form. Well, we do the same thing. We already know that this is point. This is one of the direction vectors. This is another direction vectors. Yes, and then we can take n to be u cross v, and this is 1, 1, 1. This is a good example to do more dot products, cross products. Please go ahead, pause the video and do it yourself. You can, and then you will see that you get something like this. One, you apply the trick or whatever method you can work with. Works for you. This is 1 times -1 minus 1 times 2, and this is 1 times 4 minus 1 times -1. And as a result, we get -2 first one, -3 the second one, and then 5 the third one. Very nice. I have n. Well, then the rest is just what we did. Yes, nx equal to n dot p. This is -2, -3, 5 dot x, y, z equals to -2, -3, 5 dot. The point, well, it's given there, -2, 1, 0. This gives us -2x, -3y plus 5z equals to 4 minus 3 plus 0. So the final equation, the general form is this guy. -2x minus 3y plus 5z is equal to 1. The third one seems a little bit different because this time the given information is 3 points P, Q, R on the plane. Well, how we can then find, well, we're going to write the general form, so we need a normal vector. How we can find a normal vector here? This is the trick. If I find the PQ vector and PR vectors, these two vectors are going to be parallel to the plane. So I have pair of parallel vectors or direction vectors, and then when you cross product, you get n. That's how you get n. So n is going to be PQ cross PR, and that is, well, I know what is PQ. This is position vector Q minus position vector P, and that will give me, so 0, -1, 1, minus 1, minus 2, minus 3. This is going to be crossed by R minus P. So 1, 0, 4, minus 1, minus 2, minus 3. This is the vector -1, -3, and -2 cross 0, -2, and 1. Well, you do the cross product here. I won't do the details. Well, just quickly, -6. I did, yes. This is good. Let me see. -3, 2, -1, 0, -2, 1. Yes. Okay. -3 minus 4 will give us -7. Then -2 times 0 is 0, minus -1, which is 1. And then -2 times -2 is 2, minus 0 is just 2. So we found the normal vector. Now that we have normal vector, nx equals to np. Here, n is -7, 1, 2, dot x, y, z equals to -7, 1, 2. What is the point? Well, you can pick any of these points you like as the point that you're going to use in the normal form. So I will use the point P as always. So 1, 2, 3 is that. This gives us -7x plus y plus 2z equals to -7 plus 2 plus 6. As a result, this is -7x plus y plus 2z equals to -7 plus 8. That is equal to 1. That is the equation, the general form equation for the plane containing these PQR points. So all these examples were for the first part. Basically, you have two vectors. You want to find the third vector, which is orthogonal to both of these ones. And remember all these things happening in R3. Cross product works only in R3. Okay, so then how about the other one, the length property? Well, the length of the cross product is equal to the area of the parallelogram, and then I have these examples prepared for you. Find the area of the parallelogram determined by these two guys. So we know that the area of the parallelogram in this case is equal to length of u cross v. We have to find u cross v. These are the same u and v that I used in the first part of the example 1. So if you check it, we have u cross v -1. So we are trying to find the length of -1, -6, -2. Well, I'm using the same vectors there. So then the length, remember, square each component and then add them. This gives us √1 plus 36 plus 4, and that gives us √41. The area of the parallelogram determined by u and v is √41. How about the triangle? So the area of the triangle is equal to, not to the length of u cross v. Remember the triangle determined by u and v has half length of the parallelogram determined by u and v. So in this case, basically what we have is that we have to find half of the length of u cross v. Well, again, this u and v are the vectors that we use in part 2 of example 1. And the cross product gave us -2, -3, 5. So this means that we have half of root -2 squared plus -3 squared plus 5 squared. These add up to 25. 9 is 34 plus 4, 38. That is the area of the triangle is half of root 38. Let me write it a little bit different form for you. Yeah. How about this one? Okay, again, we have 3 points P, Q, R. You can form two vectors PQ, P, R. These are giving you a triangle. The area of that is going to be the half of length of PQ cross PR. And PQ, PR, the cross, again, I'm using the same points in the as the previous example. The cross product was -7, 1, and 2. And don't forget that half, because that is going to be very important. -half squared plus 1 squared plus 2 squared. This is half. 49 plus 1 plus 4. This is, yeah, this is 54. Let me just, yeah, this is root 54 over 10. And that finishes the examples. Two types of examples. The ones which involve the length of U cross V, the other ones which involve the direction of U cross V.